Okay, this is Unit 1, Video Lesson 1, and this will be the first time you've practiced a video lesson for Algebra 2 with Mrs. Baker. And so what we're going to talk about is the absolute value parent function today. Yesterday in class, or the last time you were in class, we talked about the linear parent function. Today we're going to talk about the absolute value function. The absolute value function looks like this. As far as the equation goes, y equals the absolute value, that's what these are, the absolute value of x. Okay? So what does this mean? If I say y equals the absolute value of x, it means that all the y values will be, so the y values will be the absolute value of x. Well, it actually means the y values will be the positive x values. Okay? So the y values will be the positive of the x value. So if you tell me the x value is 1, then the y value is 1. If you tell me that the x value is negative 1, then the y value is the positive of that, and positive of negative 1 is positive 1. So when we graph it, then we're going to look and see what does this graph look like. Okay, so we just did a couple of little tiny examples. I said when x is 1, y is 1. When x is negative 1, y is positive 1. When x is 0, y would be positive 0, but 0 does not have a sign. 0 is not positive and 0 is not negative. So if x is 0, then y is 0. Let's try 2. If x is 2, the positive value of that is also 2. And if x were negative 2, then the positive value of that would be positive 2. So now I'm going to come over to my graph, and I'm going to try to plot these points to the best of my ability. So I've got 0, 0. When x was 1, y was 1. When x was negative 1, y was 1. When x is 2, y is 2. When x is negative 2, y is still positive 2. Right there. Okay? And if I connect this side looks like a line with a positive slope. And this side looks like a line with a negative slope. But if you put it all together, it looks like a giant V. So I try to remember this by saying the absolute value graph looks like a V. V for value. Okay? So if that's the parent function, I'm going to draw it one more time a little bit darker so you can all see. If that's my parent function, we're going to do some transformations with this just like we did with a line. So let's try a few of these. The first thing we're going to do is we're going to take the parent function of absolute value of x and we're going to add 3. And because we're adding 3 at the end, then we are transforming this by shifting it up 3 places. So what that means is the v that we had before, and I'll go back to it, this v that we had before, we're going to shift this up 3 places. So 1, 2, 3. This is my new center. And now this side is going to go up, and this side is going to go up. Okay? So we have the absolute value of x plus 3 shifts the whole picture up 3 places. How about if we do the absolute value of x plus 3, where the plus 3 is with the x inside x world? So if it's inside x world, it always goes the opposite of what we're expecting it to do. So we're expecting this to be plus 3, so we want it to go to the right, but since it's in opposite world, it actually goes left. Left 3 units. So I'm going to go left 3 units. That's where I'm going to put my center point. And then my graph still goes up and to the right and up and to the left. Still makes a giant V. It's the exact same V, it's just been shifted 3 units to the left. Okay? Let's try another one. What if we do y equals 2 times the absolute value of x? Now I'm going to leave a little space this time because I want to show you something a little extra. So if you have the 2 on the outside, what does the 2 do? Well, the 2 works like a slope. It's not exactly a slope, it's more of a sort of slope. Okay, so I say it's kind of a sort of thing. It's not exactly a slope. So what we do then is, where before we had our points at 0, 0, and 1, 1, now with a slope of 2, that means our new graph, our new xy, is going to be 0, 0 still, but when x is 1, we'll have 2 times x, which is 2. So we have 0, 0, and we have 1 is at 2, and we're going to continue that slope, up 2 over 1. And then I'm going to connect those dots, and it's just going to make it be a little bit skinnier. Now, because absolute value functions have symmetry, I can actually come directly across from that point and draw this part of the v. And you can see that I still have an absolute value v, but the slope is 2, and so it's a skinnier v. Now, if my slope were, say, 1/2, don't forget you can rewind if you missed something before I started erasing. If my slope were 1/2, then what it would do, and switch colors. Okay, so if my slope were 1/2 absolute value of x, and we did y equals that, then when I plug in 0, I would still get 0. But when I plug in 1, I would get 1/2. So at 1, the slope would be way down here at 1/2, and the symmetry slope would be over here at 1/2, and my center would still be 0, 0, so you can see this one would actually be much wider. So whole numbers are going to give me a skinnier graph, and fractions are going to give me a wider graph. Okay, now hold on. I'm going to erase this one more time. I'm going to give you one more. What if we didn't want this to be skinnier and we didn't want it to be fatter? We actually just wanted it to be flipped over. Okay, so I'm going to flip this over. What if I said y is negative absolute value of x? Well, this negative tells me that we're going to reflect or flip my graph. So we know the absolute value graph looks like this. So when we flip it, we're going to come across the x-axis and we're going to give it some symmetry. So let me show you that on a brand new page. Okay, so if we reflect it, we're going to have 0, 0. When you plug in 1, the absolute value of 1 is still 1, but the negative makes it negative. When we plug in negative 1, the absolute value makes it positive 1, but this negative on the outside keeps making everything negative. So we're going to have 0, 0, we're going to have 1, negative 1, we're going to have negative 1, negative 1. Let's try that again. And when I connect my dots, it's going to be the same absolute value picture, but it's going to be reflected across the x-axis. Okay? So we have shifts to the right and left. We have shifts up and down. We have slopes that change this to be fatter or thinner. And we also have negatives, which cause this to be reflected. All right, so let's try to put this all together. For this one, I have 2, and I have x plus 3 together, and I have plus 5 at the end. So what do each of these things do? Well, this 2 changes my slope. This plus 3 changes it left 3 units. This plus 5 moves the whole thing up 5 units. And so I imagine to myself, what does the usual graph look like? Let's see, so I'm draw right over here, just a plain old V. Put little arrows. So we know with our domain and range, it's going to keep on going. So the one that we're going to do is going to change because the slope is going to change. It's going to move left 3 places and up 5 places. So here's what I like to do. Absolute value graph is usually right in the middle at 0, 0. If I move left 3 places, if I move left 3 places, hold on just 1 second. Okay, if I move left 3 places, like I was trying to say, I'm having trouble here. 1, 2, 3, that's going to be my new starting point. Up 5 places, so 1, 2, 3, 4, 5. Of course, I'm going to run out of space because I didn't plan very well. And my slope is going to be 2, so from here I'm going to go up 2 over 1 to make that slope. And I'm going to mirror it up to back 1 to make it that slope. And that's the ugliest picture I think I could ever have drawn. So I'm going to back it up and I'm going to start it again. Erase. Okay, so remember this. We're going to go left 3, up 5, slope 2. Left 3, up 5, slope 2. Okay, let's give myself some more space. Left 3, up 5, slope 2. Here we go. I'm still not doing a very good picture, you guys. Let's try again. I'm down here. So I'm going to go left 1, 2, 3. I'm going to go up 1, 2, 3, 4, 5. This is my new center right there. My slope is going to be up 2, right 1, which gives me my new line that way. And then from here in the center I go up 2, back 1, which gives me the slope that way. And that's my graph. That's what it looks like. Okay, now I have some tricks for you. And they're really pretty straightforward. This is going to be moved to the left 1, so I'm going to put left 1 right there. And this is going to be moved down 6, so I'm going to put down 6 right there. What this does for me is it tells me the vertex of my absolute value graph. And the slope is right here, so the slope is 2. So when I go to graph this, I'm going to use a blue graph this time. When I go to graph this, make sure I give myself enough space. Vertex is at -1, -6. 1, 2, 3, 4, 5, 6. There's my vertex. My slope is 2. So I go up 2 over 1. I don't know if you can see me drawing that right there. And then I draw the graph. And then I do up 2, back 1. And I draw the graph. Try to keep a straight line. There's my graph. That's all I had to do. So the vertex is -1 and -6, and the slope is just 2. All right, got a little bit more for you. Oh, that's what we just talked about with the graph. Okay, instead of talking about the graph right here, let's talk about the transformations. My program's messing me up a little bit. Transformations. What are the transformations? Well, in our previous graph, my transformations were a horizontal shift, and how many places did we go to the left? 1 place. So horizontal shift of -1. -1. We have a vertical shift of -6, or you can say down 6. Just like up here we could say left. And then the 2 was called a scale factor. So the scale factor was 2. So it's 2 times skinnier, or it's skinnier, or you could call it a shrink because it's skinnier. It's a shrink by a scale factor of 2. Okay, now we're down to your own part for your notes. So this is on your own. It's in your spiral. You can call this your note problem. All you're gonna do is you're gonna graph and discuss this problem right here. And when I say discuss, I mean the transformations. Okay, is it up? Is it left? Is it right? Is it down? Is there a shrink, or is it skinnier, or is it fatter, or is it reflected? That's what we're talking about. And this is what you show me in class tomorrow.